Hi folks, for the next part of the tutorial, we are going to be hands-on, which is why I'm quite closer to you than I was before. I need to use my keyboard. We are going to be using one of the environments that we talked about, and that is a single container. So if you're a developer, you want to quickly test something with Flux, shelling into a container that has your entire environment ready to go is a really good path to take. So let's do that right now. So we're going to do Docker run IT. IT means interactive terminal. Flux RM, that means Flux Resource Manager, then Flux Sched, that's the name of the container. And then the tag is, I think, Jammy and, oops, wake. I am awake. I don't know. I know it's 6 a.m., but like seriously, the container has me. I mean, to be fair, it's not wrong. Follow the riddles. Okay, I see where this is going. Everything that you know is in Flux. Nice, but you're nicely done. You know what to do. I know what to do, as if I've ever known what to do ever. Okay. Audience, don't panic. We appear to be in a cheese abyss. And hello, friend, to escape, you must find Flux Bird. Okay, so change of plan. I was originally going to be doing a tutorial, and it looks like now we are going to be on an adventure together to escape from this container, which is definitely some kind of Linux admin's nightmare. That's okay. So let's do the obvious first and see if we can find Fluxbird. Fluxbird! I don't hear anything. Okay, no, not a problem. Don't panic. Let's look around. Fluxbird. Oh, don't run me. I mean, we kind of have to run it, right? Like, oh, I'm just like diving right into this trap. Don't run me. Ah, they promised riddles and they're delivering riddles. To start with our fun, there's a little bit of work. You must run. That's a clue. But first, you need 4 nodes. Physical nodes have appeal, but they don't need to be real. All right, so I know exactly what this is talking about. In Flux, we have an ability to create fake, kind of emulated nodes. We can do that with Flux start, and we give it test size equals 4. So then what this is actually going to do is start a Flux instance that makes it look like we have 4 nodes. We can figure out the resources available to us in the current instance with Flux resource list. Boom, 4 nodes, 32 cores. So what this has actually done, we exit from the instance for a second, and we just look at Flux resource list on my actual machine. I just have 1 node with 8 cores. So it basically multiplies it out by 4. Now, this doesn't mean that my computer actually has 32 cores and I can abuse it like that, or at least this Docker environment. It just means that I can test things. So I can do Flux run n4 hostname, and then it's like I have 4 nodes. Okay, so we are following instructions. We have our 4 nodes. And what did they say again? Physical node. There's a little bit of work you must run. Work. Oh, I I do believe there's a little bit of work we must run. Okay, so I mean we know what to do. So Flux run n4. It wants 4 nodes. And let's run the work, shall we? Ah, we did it. Okay, good job, Padwin. What is this, a Star Wars thing now? We've gone from like keys to Star Wars and like the same. Who made this container? This is node 0. This is node 1. Okay, that's the Flux task ID. By the way, in a Flux job and a Flux instance, you have a bunch of Flux environment variables. So if I do Flux run n1, and then I just do, actually we can just do environment, grep Flux. There's all the stuff. You have the job side, you have the number of nodes, the job ID. This is really useful when you want to do programmatic stuff and you just want to grab it from the environment. Anyway, I'm getting distracted. What was the next terrible riddle? Your next task is in the bin, something you need to do on a whim. Okay, well, we know that Linux has a bin. It is a very full bin. something you must do on a whim. Okay. Oh, all right. We found it. We solved this riddle. Something you do on a whim. Batch me, baby. Okay, we're going to batch it. So flux batch is akin to S batch in Slurm. And what you're basically doing is you can have like a bash script that has directives at the top. So I might write something like flux. And the idea is that you put this directive and then right after it, you put anything that could be a command line flag. So I could put N4, I could put little n 32 for the number of tasks. I could do cores per task equals something. I could do CPU affinity equals per task, anything there. Anyway, they have already written a say script, whoever this container owner is. So let's do flux batch n1, and now we're gonna do this on a whim. That's exactly what we're gonna do, right? Okay. So what you're looking at now is a flux job ID. It has that curly F. That is what is generated whenever you submit. So if I had done flux submit N1 host name, there's another job ID. Now a trick that I can't use now because I just submitted another job is actually to use flux job last. That's going to get you your last job identifier, which now is the host name. So if I were to do flux job attach flux job last, what do you think we'll see? We are going to see the host name. Ta-da! Same. Okay, we're getting distracted though. So what we need to do is we need to see this job ID. We need to see the output for this job ID because this is what's going to get us out of this container, right? So flux job attached. Now we're going to copy paste that. So because it's a batch job, the idea with a batch job is that you actually you want to create kind of a parent level instance and you want to create sub instances to do specific kinds of work. So I may create a batch job that has, CPU and GPU. The idea being that I want to use the GPU for machine learning something and I want to use the CPU for simulation. Then within that flux job, I may do a flux submit for the GPU resources and the machine learning thing, and then the flux run for the CPU. And so because of this different design, that means that it's expecting you to basically do that. And so anyway, we have to look at this particular output file. A world of cheese, a joyful spread, from softest brie to cheddar's head, each creamy bite, each crummy art, a simple pleasure for the heart. But in my bin, thoughts now stray. Clearly someone sitting in the bin writing poetry. To golden flakes that make my day, a certain dish it waits, you see, for Parmesan's sharp company. That nutty zest, that crystal bright is what my terminal lacks tonight, a missing star, a flavor hunt. A cheesy promise I should want. Run me again, this time with zest. Try again, this time with zest. Okay. Okay, so there's a couple things in here. It appears that the evil entity that is trapped in this container with us wants cheese, but doesn't want just any cheese. They want Parmesan. I think I have some Parmesan. I'll be right back. I have Parmesan aplenty. Okay, you see this evil force? I brought you Parmesan. Now what? Okay, what do I do now with this Parmesan? Run me again, this time with zest. Okay. With zest. Actually, let's run it again. Flux batch. So let me show you now how to define environment variables. So if you want to add an environment variable to your job, you do env with zest equals yes. And then basically the same thing. So I'm guessing this is going to be, now we can do flux job attach, flux job last. Now this is, it seems to be, now it's doing something different. We see that it's actually hanging. Because we're attaching to the job, the fact that it's hanging tells us that it's still running at sleeping. So I'm going to do Control Z to detach. I'm going to do flux jobs to verify that it's still running. So by the way, to see your queue, you do flux jobs. If I add flux jobs A, that's all of the jobs that I've run. Oh, that's interesting. So let's look at this output file. We submit 3. Oh, interesting. Enter the instance and find the next clue. I'm going to sleep. Well, we knew you were going to sleep because we saw that. Okay, so what you're looking at here is called a Flux URI. The idea is that every Flux instance has a URI like this that you can connect to. Matter of fact, whenever you're in a Flux instance, you can just echo that variable and you're going to see it. So notice how these two are different. The one that I just echoed is the instance that we're in now. The instance for the job that we just submit is a child instance. So in order to enter it, we are going to use a command called Flux Proxy. And the way that Flux Proxy works, actually, let me show you. By the way, for any Flux command, just look at the man pages, and there's usually a lot of good information here. So the idea with Flux Proxy is that you can connect to a Flux instance. How many ways? Many ways, just as many ways as you can make something with cheese, which is a lot of ways. So the first way, let's kind of scroll down here. If we look at the first one, so the local path, that's the one that we have. That means like it's a local file. Another one that you'll most commonly use is SSH. So that means you can have a machine that you have SSH access to running a Flux instance, and you can Flux proxy to either connect to it or just to submit commands to it, which is pretty cool. We also have the ability to connect to job IDs specifically, although I don't particularly use that as much. Okay, cool. So let's go into our instance and see what we find. So we do Flux proxy, and I'm going to give it bash so I get an interactive shell. So now we do Flux resource lists. Notice that we only have one node because, well, that's kind of what we asked for. So, and there's the next clue. This is getting really long, isn't it? Okay, I'm tired too. So let's look at the next clue. One job ID is a good test, but expand on that, and Flux Bird will make his nest. Is like Flux Bird nesting somewhere? Is Flux next? Does Flux Bird have a family that we don't know about? Okay, so let me tell you about what you can get from a job ID. When you start with a traditional Flux jobs A, this is really where you probably would go to get a job ID. But as I showed you, I like to use also Flux job last. I don't want to copy paste. Now, let's say that you're in a terminal and you copy paste that curly F and it does something really weird because it's an old terminal. You can actually get this job ID in different formats. So we're going to do Flux job ID for Flux job last. There it is as an integer. That's much easier to see. But what if you're a user on a supercomputer and your job is Borky and you need to call the hotline? Do you really want to read them out a long number? No, you don't. You want to give them something else. You want to convert it to words, and you want to say, yes, my job, Guitar Race Quiet Active Academy. It's having some trouble. Could you take a look? And the admin will be like, of course, but I don't speak words. Could you actually give that to me in emoji? Why, yes. It's a love letter video game console watermelon running man. Understood. I will look into that for you. So anyway, this Flux job ID is a way to convert between things. But the other thing that you can do with these job IDs that I really like, so if we just do Flux jobs A, that shows us the jobs. But what if I want to do something programmatic, right? I can add JSON. Oh, okay. All of a sudden, there's a lot more metadata than there was before, like different timestamps when events happened. I'll show you that in a little bit. But importantly, I want a programmatic way to loop through my jobs. So I might do Flux jobs A JSON, pipe that into JQ. Let's add R for raw. And then let's look at jobs. That looks to be a list. And then let's look at the ID. There we go. So there's our Flux job IDs. So now we can do something cool like for job ID in that do, and then we'll do Flux job attach, job ID, done. There's our poem. We now have a job ID. and you could hypothetically loop over this. But let me show you some really cool ways to interact with Flux metadata. So if I do Flux job info, job ID, it's going to give me all this stuff that I can ask for. So I can ask for the J. This is the signed job spec, not intended for a human to read, but by the way, it is signed for security. If I do Flux job R, this is the resource specification, and I know that's going to be in JSON. So that looks like that, or without the JQ. If I do event log, this is really nice because it gives you all the timings of everything when your job was validated. It went through depends, Alex, start, finish, release, free, clean. This was a really quick job, so those are all close together. But this is basically when we run experiments, how we get the total wrapping time around the job. Okay, what else can we see here? There's the event log. We already saw that. There's guest.output. We know what that's going to be. This is basically going to be every line of the std out, except it's going to be wrapped in a little JSON structure so you can parse it. Okay, so you could imagine doing that in a loop and basically saving stuff to file or however you please. And actually, we do that all the time for our experiments, and it's really nice. So let's have a little fun. Just because I want to be stupid, let's do Flux submit. Actually, we'll just do one task each, and we'll do. Actually, let's do for I in 1 through 100. Do let's live dangerously. Flux submit, and I'll just do posting. So that'll by default use one little task. I hope this works. Okay. This is very slow. Yep, this is very slow. So the last little thing I'm going to show you before we go disturb Flux Bird out of his nest is how to do this more quickly. So if you do Flux submit and you add CC, that means carbon copy. So I'm again going to do 1 through 100. And I'm going to add watch, progress, JPS, which means jobs per second, and hostname. Ready? Boop. Okay, so now we're going to do a loop. Let's see, for job ID in Flux jobs A, GQR, do Flux job ID, Flux job ID to emoji job ID. Yeah. That was just for fun. I don't know why anyone. I like that it's like that. Okay, so I was promised that after we talked about more jobs, we would see Flux Bird's nest. I don't see the nest. Maybe Flux Bird is not nesting in my present working directory. Let's look around. Ha! We found the nest. That was easy. It's almost like I wrote this container. Almost like I gave a nest. Oh, Flux Bird. Should we run it? Running directly without help. Tisk. Create an allocation first. Fine. Okay, so when you're on an HPC system and you want an environment to develop in, so you want to create an instance, but you want to be sitting in the instance to do work, you can do Flux alloc, again with some number of nodes, and then you're in an instance. Okay, alloc and once. So we created the allocation. Flux Bird. Are we still in temp? Bash. Fluxbird.shell. Oh, you little demon, what are you doing? Wait, do you hear that? Is everyone okay? Okay, I'm in one piece. Feel myself. I am not injured. I don't know what happened, but I think the container exploded, which means we got out, but I'm not sure we found Flux Bird. Let me look around here for some kind of light to turn on. Oh my. I appear to have activated an emergency system. I think that means that the lights are going to come on soon. Just hang in there with me. Hey, let's find some lights. Ah, let there be lights. I'm wearing pink. I wasn't wearing pink. Oh, Flux Bird. How did you get there, folks? We found Flux Bird. So apparently Flux Bird was probably terrified, as I would be, as I was, for this explosion, and he decided to hitch a ride on my head. Well, Flux Bird, I am totally okay if you want to ride on my head. Just don't, do that thing that birds do sometimes. And it appears that we are in a different environment. Which environment? Guess what? We are on a Slurm cluster, a very small Slurm cluster, but yet still a Slurm cluster. We have a particular thing we talk about a lot. That is the ability to run Flux under Slurm, so in user space. So some prerequisites, we're assuming you're a user and that you've installed Flux. So you can actually install Flux to user space by doing the traditional like git clone. You'll build them with either auto tools or CMake. It's a couple of git clones. Or what I like to do is actually just install from Conda Forge, and I usually use Mamba. So we actually have an environment with Flux. And if we're just sitting on the login node, we could technically do Flux start, test size equals 4, and get a Flux instance on the login node, so Flux resource list. There's our node list, but we actually want to be in a Slurm allocation, right? So let's start from scratch. So let's do salloc. Let's ask for 2 nodes, exclusive. Hey, we're in our allocation. I don't know if you can see your allocation from here. There it is, we can see it. Okay, so now we're gonna do srun. We are going to ask for MPI with PMI2. And then we are also going to ask for 2 nodes. Why not? Because we technically have 2 nodes for this job ID. We're going to ask for PTY for an interactive session. And then we're going to give the full path to Flux. So that's opt conda bin Flux v for verbose. So we kind of see what happens. And I think this is going to work. Let's do it. What do you think, Fluxbird? Yeah. Oh, you're on this side. Okay. Fluxbird says, yeah, let's do it. Okay. Okay, what did I do wrong? Ah, this should be PMI2. My bad. MPI is PMI2. There we go. Alrighty. So I think that worked. Now we did it with verbose, which is why we see all that stuff. Flux resource list. There you go. So that, what we just walked through was one command to create a Slurm allocation and then launch Flux under it, where Flux is installed by you. Technically, Flux could also be installed as a module or by your system administrator. But the point is now you get all the features of Flux, but running under another job manager.